As we are doing this, as we take a look at question number 9 on the back. Number 9, all of these are equations. The key word is telling us that we need to have an equal sign. So when I take a look at number 9, it says the sum. This word sum, and then when you see the phrase and, that's telling you where to put the plus. So when you see the word sum or the difference, and then you see the phrase and, that word, that's telling you where to put that addition sign. So I have 8 plus, it says the quotient of C. Quotient just means the answer to division. So I know I'm dividing, and then it says C divided by 7. So C over 7, and it equals 11. Oh, Mrs. Thompson, I wrote mine this way. I put 8 plus C divided by 7 equals 11. Those are the same. Quotient of C, since they have a C right there, I use a C. I'd be okay if you have an N or a C, whichever variable you'd like as you look at that. Jacob, did you have a question?
Oh no, it was not the test, but is it actually over, out of 100?
It was 60 points, and then I put that scoring out of 100. Okay.
I put C because I said plus 8.
Same thing, right? Addition can be commutative. So this would be the same if I have, so when we think about, because addition is commutative, you could have said the sum of, and you put the quotient, the C divided by 7, and then you add 8 and it equals 11, same thing, right? When does order matter? When we're doing subtraction. So I look at number 5, it says the quotient of a number divided by 6. N divided by 6 equals 5. Oh, can I write it this way? N divided by 6 equals 5. Same thing as I'm looking at those, right? As we look at those last ones, number 13 and 15, and my hint would be, if you are really struggling with these, is to make sure, as you look at number 13 up here, 13 says we're putting 53, is our equal, 1 more than, that means I'm adding, 1 more than, twice a number of students in the class, 2 times n. I do not want to have a 2xn. I want to get away from that. I either want to put 2.n or I just want to put 2n. Someone said, well, could I have had 53 equals 2n plus 1? Addition is commutative. You can write it either way. Okay? I am not doing 15 because what 15 is asking you to do is to write out something like one of these and you come up with your own. So when you're trying to think of multiplication for the 6 and the x, you could use product, could use the word times, and you can look at your notes from yesterday and think, what are all those multiplication words? And if I'm taking 6, okay, so the product of 6, and then I'm going to subtract. So I might decide, do I want to use the word difference? Do I want to use less? Do I want to use less than? Do I want to, you have to make up, so I want you to have your own phrase, okay? On the daily planner today, what I did is as you look, and we're looking at over here, I put up the answers for C1 and C2, so I have them for both of them. Next week, I'll put up for the rest of those, so that if I was looking at this, and I know they don't show up real dark, and I think it's because when I did them in pencil, or like I did them in pen, but when I scanned them. So here's the first page of that. Please correct. On the very first page. What do I mean by correct? I mean, if you got it wrong, I want to see a check mark, right? So here's 1 to 10, and then I'm going to move it down in just a minute so you can see the rest of this. Now, if you didn't do it like this and you have something similar, by all means ask and I will check with you. Yes? I thought I had mentioned in yesterday's notes, so I want you to look back, but did I say write this down with the phrase less than? Did I say put that with subtraction and do, like show this? Because I helped a couple people this morning and they didn't have this in their notes. Yeah. So if I say 2 less than x, because I thought I said this yesterday. Oh yeah, you have it. Oh, perfect. But there was a lot of people that said, you know what, but I always copy down what you say in your notes, so please go back to the notes from yesterday And I think I could even probably have pulled it up on the daily planner. But this phrase, I asked you to make sure you put this down, that this means x minus 2. And that anytime I have the phrase less than, I have to switch the order. And I had a couple people that I was helping with, and I'm like, did you write it down in your notes? Well, yeah, I write everything down that you say in your notes. Well, we'll just check. But so when you leave class and you think you have everything, but you know what? Maybe you didn't. If you go back to the notes and you go, oh, there it is right there. 2 less than a number. There was a bunch of you that didn't have that down. Write it down now if you don't have it.
Oh, I have it.
So when you say to me, Mrs. Thompson, I didn't get this phrase less than when I'm doing my homework, you got to have all this down. I'm not doing this just because but if you're struggling with that, that's what you want to go back to. Okay? All right. So, today, we're going to continue. Okay? We are continuing in your notes in lesson C2, which is called Simplifying Expressions. Abby, read the first I-can statement, will you? The rest of you, shh, quiet, please. So that's what we were talking about today, like the commutative property. Can we have 4 plus 3x? That's the same as 3x plus 4, right? That's the same thing. Associative property, remember that's when we were talking about moving the parentheses, okay? Distributive property is the one that we're getting today, to generate equivalent. And it says I can explain equivalent expressions in a problem context. So, keep calm and combine like terms. So, what is that? So, keep going in your notes, please. We are looking at that part down below. It says a term can be a number, a variable, please write that in, or the product of a number and a variable. Right below this, I want you to put, or right behind it, either one, let's go right behind it, example. The number 4, that is considered a term. 3x is considered a term. 7xy is considered a term. Negative x, that is a term. This one is just the number. The rest of them have numbers and variables. The product, meaning they were being multiplied, right? Okay, just like, let's just go through some definitions and then we can worry about the not. So like terms. This is going to be terms that have the same variable raised to the same power. Okay? So, in this example, I say all of these are terms. The constant term is the one that has no variables. The constant is only numbers. So I say, what's the constant term? Up here, the constant would be 4, right? From up above, this would be our constant. 19 would also be a constant. It is simply a number, no variable. The word coefficient. Coefficient is what when we're talking about the number, and I know for me this was kind of a small space to write, the number in front of the variable. What it really means is not just in front of the variable, it means the number times the variable. So, up on the top, I wrote these different terms. So they say in this example 6y. So we're going to write 4x down here plus, right, minus 3y plus z minus x. I am you next week on a quiz, probably next week, Thursday. It's going to be a bigger quiz. I'm going to say, what are the terms? And I'll just put this word and ask you to list them. So, if you were going to start listing them, you would start with, the terms are 4x, comma. Should I put 3y or negative 3y? Negative 3y. Okay. Okay. We should have z, and we should have negative x. And I heard some question like, why shouldn't we put just 3y? Remember, anytime you have subtraction to make your life easy for the most of pre-algebra and algebra and the rest of your life, subtraction, remember subtraction means adding the opposite. Subtraction means we can change it to adding the opposite. So if I'm adding the opposite anytime where I see subtraction, okay, I'm going to change this to plus and I'm going to make that a negative 3. And I'm going to make this plus and I'm going to make that a negative. So if I say, okay, those are my terms, and I say, what are the coefficients? Okay, so I want you to just write down the coefficients of all of our terms. So write it right now, and then I'm going to have you just check. I'm going to put it down in just a minute. So write the word coefficient. The first coefficient, 4. The next coefficient, negative 3. The next coefficient you're seeing, raise your hand. What do you think? Caleb. Kaden. Sorry. You see nothing. Like 0? Shh. Like 0 times z or 1 times z? Anyone have any thoughts? What do you think, 1 or 0? What do you think, Jaden? Why 1?
I guess.
Yes, you guessed right. Okay. The reason it is understood mathematically, if there is no variable in front, that this is the same as just z. And a lot of times in math, they like to shorten things up. We just don't like to write a lot of words and keep it simple, right? So simplified form of 1z is to just write z. But we all have this understanding, and we think everyone understands like us, that anytime we put a variable, if there's no number in front, it's understood to be a 1. The reason it's not 0, if I have 0 times z, that's 0. So that's why it's not a nothing. So I have a 1 here, and then my last one would be, careful,
Negative 1.
negative 1. Okay? If I asked you, Jack, you right with us? Okay? If I asked you to tell me do I have any constants?
No.
Okay? So if I say constants, what were they? We have none.
We have 1.
Okay?
No, you don't. Yeah, we have 4.
In this phrase, right here, none, right? So if I'm referring just up here, and if I asked you for any like terms, do you have any that look alike, have the same variable to the same power as I look at it? Whitney, what do you see that looks the same? Same variable. Which letter? Maria, what do you think? X. We have a 4x and a negative 1x. Those are my like terms, okay? So the quiz next week and then your homework, I'm going to ask you, what are the terms? You're just going to list them. What are the coefficients? That just means the number that's times that variable. Constant is the number by itself. So vocabulary. Again, you're struggling with vocabulary, make a flashcard. I'm not going to make you do it. So take a look at this one on the top of your next page of your notes. And it says, okay, these are examples of like and unlike terms. So if we have 7 and negative 3a, it says, what's their variable factor? Both a, are they like terms? Yes. 4x squared, 12x squared. Both x squared. Oh, this one is a definite no, because you have a, b, and you have a. And in the last one, they look so close, don't they? They almost look like, but it's the x here is to the first, and y is to the second, and so it is key that those are not the same, okay? When you are going to be adding like terms, what we are going to do is we are going to group the coefficients. So here's going to be your coefficients, right? What were the coefficients of A? 7 plus -3. And then we have an A. Can we add 7 and -3? This is going to give us 4A. Okay? If we are looking at this next one, please put in a parenthesis right below in your notes. 4 plus the 12. Why are we doing that? Those were our coefficients of our variable. Then we're going to keep it x squared. 4 plus 12 gives us 16 x squared. And someone always says to me, well, why shouldn't it be x to the 4th? Because we got 2x squareds. I want you to think about the unit we just finished with exponents. If you have x squared times x squared, that's the only time you're adding the exponents, right? That's how we get x to the 4th. If you add an x squared and an x squared, you can't. It's just x squared. So like terms can be added. Like terms can be added together. Unlike ones cannot. Okay. Here is what you're going to be looking at. So they kind of write it in many different forms. Okay. We talk about the coefficient. We had two terms. If I ask you, our variable was x, and the constant in this case is the constant 3 or -3. The constant is, so you got to be really careful. That constant we actually would want to say is -3. So when we do the simplifying, here's what I want you to do. I want you to use that parenthesis like I did, and I want you to put the coefficients inside. Okay? So this first one, we're going to start with 3 plus 6 times b. 3 plus 6 gives us 9p. If we are looking at this next one, the question comes up is, oh, can I add all three of them together?
Yes.
No.
No. Only the like terms. So I'm going to put 9 plus. Everyone should be writing this on their paper. 5 plus 9 times the r. So I have 9 plus 5 plus 9 gives us 14r. Now, later we're going to talk about descending order when we start solving our equations and we get into some of the stuff with slope and doing some stuff. I would take this answer, but knowing we can use a commutative property, this is a better answer, 14r plus 9. And the reason being is it's called descending order. So when we talk about something being in descending order, that's when you put the largest, you put the variable, ones with variables first, and then you put the number at the end. That's what descending order just means, okay? So we're going to look at this one, and we have numbers, and we have variables. So in front of this B is what number, everyone? 1. So I'm going to underline with one line my like terms, and then I'm going to put like a squiggly line under my constants, right? So that's kind of telling me, sometimes I'll have people circle. Like they'll circle the like ones and put squares around the constants, or I don't care how you do it, but you got to think which ones are you combining. So in this case, if I'm looking at my coefficients, remember we always want to put those coefficients first, with my letter B. That means I'm adding 1 plus 2. Someone said, oh, Mrs. Thompson, I can just do that in my head. I know, but I want you to write this down, because I'll tell you the worst mistake I'll get is that people will tell me that this is 3b squared. And you can see what their mistake is. They're thinking they should multiply the b's. And it should be 3b, and then we're adding the constants together, which 3 plus 6 gives us 9. Okay? 3b plus 9. All right. So again, grouping them, put your coefficient. N add your two numbers, 36 plus 47. If you think it helps you to circle the like terms, because I'm going to put 10 plus 38 in here, and then I just leave the constants, and I'll have some people like to circle them, or they use their highlighters, or they use triangles. So please do the addition. 48n plus 83. Try 5, 6, 7 right now if you haven't moved on to those ones.
Wait,
Try.
but you said because of the descending thing, shouldn't 83 come first?
83 is a constant term, and this has a variable. So descending order means going from the largest variable down to the constant term. So this is working with our variables, because we'll get some, like that'll have an x squared or an x cubed, okay? So variable to the constant, good question. Try the next ones. I'm kind of giving you my hint. That's the coefficient part, right? The coefficient part. I know, it's the end of the week. Aren't you just tired?
You send it.
Okay. In this first parenthesis, Maddie, start me out. What are my coefficients of n? 35 plus is 1 a coefficient plus 46. Back here is my 1. 35 plus 46 gives me 71n plus 1.
Would it be 81?
Yeah.
Oh, 81.
Yeah.
81. Next one. Ellen, what should I put inside my parenthesis? Negative 10 plus 6. When I do that, it is going to give me what for an answer, Nick?
I'm going to give you -4.
Negative 4v. Again, if you're struggling with your integers, I put on a website as on the notes that you can go and practice more. If I'm looking at this next one, Maria, tell me what am I putting in my parentheses?
Negative 9 plus.
Yes. My answer, Emma, is going to be, when I add those coefficients, what do you get? Emma, you're on to this next part. Tell me what my coefficients. It is 1r, but let me get everyone a chance to, with all of you in here, I try to move it around, so I don't want to be blurted, please. All right. So Emma, inside this one for my coefficients of my variable, what am I going to have? Negative 2 plus what? Yes, negative 2 plus negative 3. Jack Thorberg, what am I going to end up with when I add negative 2 and negative 3 for my coefficient of n? Negative 5n plus 4. Okay? So if I asked you in any of these, how many terms? This one has 2 terms. Here we have 1 term, 2 terms, 2. This one has 1 term, right? So what's going to happen is that terms, I just want you to write right below this, terms are separated by addition and subtraction signs. Terms are always separated by addition and subtraction. So if I have 1 addition or 1 subtraction sign, what I am looking at is 2 terms. 2 terms. If I look at the original problem here, I had 3 addition signs. That tells me I have 4 terms in the original problem. Okay? So terms are separated by addition and subtraction when I'm looking at those. Okay? All right. So we are simplifying. Simplified means we have no like terms, no parentheses. So, yes.
Why are you switching this? I didn't really catch that part. Why are you switching? 4 plus 5 and then negative 5 and then why you switch it to negative 5n plus 4?
And did I switch what one? Alright. And what is nice for some of you is like you're hearing this the first time and then you're looking outside, you're thinking it's nice, and you're thinking it's Friday, and you're yawning and you're tired and you're thinking, oh, go back and watch this video and listen to me saying this and then think, oh, I gotta focus.
Every day.
Alright. So, what's number in front of y? 1. Let's change subtraction to add the opposite plus a negative, right? So I have 3 plus negative 1, keeping the y, right? Like terms. My answer will be 2y. Are these the same? Mn to the 4th?
Yes.
Put your coefficients. Mn to the 4th. Negative 7. I like changing subtraction to add the negative because I make less mistakes. Negative. Taylor, how much? 12. Mn to the 4th. Jessica, the next one. What am I? Do I have like terms? Yes, so I'm going to put the x squared and add what coefficients? 6 plus 2. My answer for that, Jack, to you over here.
8 x to the 2nd.
Yes. Last one. Can we add it? No. My answer, if I asked you to simplify, is 3w plus 5w squared. And actually, if I was going to put it in what I talked about, the descending order, this is one that I would have put the 5w squared first because it's a larger exponent, plus 3w. Plus, remember, commutative property, you can switch them around at any time, right? But I would just take the same problem right now. All right. The more practice. There's 2 pages of more practice. There's here, and then there's on the top of the next page. And I think let's only look at this. This is what I want you to do, and I want you to show like I did. I'm going to have you come up here and show us what you did. Okay? So, I want to see, when I look at this, I want to see like, oh, with the x's, with the x plus to get your answer, okay? This one, you have to add the x ones, you have to do the y's, and then you have to have your number. And there's only one number, one constant. So try those right now on your own, okay? And then we will look at those. Start what I have. That's my hint to start for you, okay? Negative 4 plus 8. What am I going to have for my, because these were my first 2. I'm now thinking of my y's, but I don't like this minus. So we're going to change that to plus a negative, plus a negative. Negative 2 plus negative 5. Oh, someone said, oh, do I keep this plus sign? Yes, you have to have that. Why? It separates our terms. 4x, so I thought someone had it right, plus they had 7x, and it should be a negative 7x plus 6. Okay? Oh, that's a y. Thank you. Okay? So, those of you that are like, I don't want to show this parenthesis, right, Gavin? You're showing it for me. You're putting that down when you do your homework. I know. Put it down. I want you to write it.
I have a question though.
Okay? So, let's do this next side really quick. Anyone have a volunteer that has that first one for me? Ready to come up? Go, Jack. Join your work up there. Grab that pen. How about the next one down? Anyone ready for that next one down if we're looking at it?
I didn't show my work.
No, then I don't want you to go up because I want everyone to show their work. Kylie, you want to go up there for us? Okay. The one right below his. You got that one? You want to do that one? Okay, go up there, you can grab the pencil. And you can write the answer right below too. So 4x plus the 3y. Nice work. Okay.
Can you show your work by underlining?
For this assignment, when we start this, no, I want it in the parentheses. I'm going to be really picky and kind of mean. I know. I get it. It's just that I have people make mistakes. And then just put you can just leave that, and then put the plus or minus y. Oh, that's the y. There you go. No.
Yeah, that's not it. Because actually,
Quiet, please. So, as we are looking at your homework, so this one, the 4y plus 3x plus 3z, the y's were our like terms, right? Okay? And then I'm going to move it down, that very last one. Anyone want to volunteer to put that one up? It hasn't been up lately. You got some work for me?
Oh, no.
Yeah. So work.
you got like 3 minutes of class left.
How do you erase? There's a little thing on the side of the pen. And, oh, you want it. Do you want this to be a 6? I'll erase it. Very good. Go. I know. So that means I probably can't give you your homework quiz on a Friday.
Wrestling sign-up continues today and Monday, but Monday's practice. If you still would like to sign up, please do so in the office. Thank you.
I should have had negative 9x minus 5y. Wrestling sign up. I would have either one of these answers. Alright. So, when you do your homework, yeah, it's due Monday. No! I did it. I know. It is. So, it says, write the expression that this would model. It tells you this stands for an x. So that would be how many x's? 1, 2x. It says these little ones stand for our constants, which mean that would be what? 2 plus 1x plus 2 plus negative 2x. So that's the positive side, that's the negative side. We're going to work with these algebra tiles next week. I know Gavin and Jake are thinking, oh, do I need to show this with the C plus D?
Yes.